Welcome to Coding Adventures. Today we are discussing about classes in JavaScript. So let's get started. Alright, so I'm here back on my desktop computer and I open in this code editor one of the previous programs that we created in I think 2 lessons back when we discussed about functions inside objects. So let's remember a little bit what we did back then, and then we're gonna see how we can use classes to basically improve this kind of functionality. Alright, so in this particular example we created an object and is named bubble, as you can see. We know that is object because it starts and ends with curly braces and inside has all these other properties. And this object has not only properties of numeric type, but also has these properties display and update, which are of type function. So in other words, we bundle together inside this object a few properties of type numeric and other properties of type functions. And we created an object, and then we use this object, basically we call the display and update functions inside this object. And we basically let's run the program to see what it does. We implemented a bubble that bounces around the screen, just one bubble. All right, so yeah, I think this syntax is pretty clear by now. We use it many times in the past, but it has only one problem, one big problem as a matter of fact. We can create only one object of this type. We can create only one bubble. If we want to have 2 bubbles moving on the screen, or if we want to have multiple bubbles like the one we did in the past, we have to do something else about this one, because obviously we don't want to replicate this entire code and duplicate it and have bubble 2 or something like that. That's probably not something that we want. So one of the things that we did last time, and we are moving in the second example, we created a factory function basically named createBubble that was basically returning this kind of objects each time this function was called. And then we call this function just once in this example, but then we have other examples in which we call it multiple times and place the objects in an array, and we had plenty of bubbles bouncing around the screen. Anyway, we don't go over the other example. So just let's run again this program, and it's again the same bubble, implemented again with objects containing numeric properties and functions. And what we did back then, again, we created this factory function that returned this object. And the idea behind creating this factory function was basically to have a way to return or to create quickly multiple objects of this type, right? Because in this way, as you can see, we don't have to duplicate the object anymore. We can just call createBubble, and the new object will be created and returned to us. All right, so let me close these two these two functions really quickly here. And actually we're gonna discuss today, I have a brand new code page here, and we're gonna discuss today about classes and how classes help us to implement the same kind of functionality but in much a nicer and standard way. All right, so what is a class? Let's start with perhaps the basic and most simple example of them all, and let's define really quickly here in the code a class. Let's say this one, class person. And the syntax for this one is exactly like I'm writing here. You write class, and then person is basically the name of the class. In this case, we want to have a class to basically represent a person, a person like people, person, and that's why we call it like that. There are no parentheses after this one in case with the functions. It's just like this class person, right? So the idea with the class is that we want to create and linking into examples that we just shown, we want to have this kind of functionality where it's easy for us to create those objects. For instance, we want to define this kind of person class, and then out of this class we want to create objects. In other ways, we're gonna use the class as a template for those objects. So instead of having that factory function that creates objects, we're gonna see how we can use this new syntax of defining a class like a blueprint and template for a thing, and then return objects out of it. All right, so first thing is to define the class, which is basically using the syntax that you can see here. And classes have a special feature called constructors, basically. So let's define really quickly a constructor, like just like that, constructor. And a constructor is basically a special function. And I'm placing this constructor inside the person class. And the special function that basically is called each time we ask the blueprint to create a new object. Notice the syntax here. I said this is a special function. We don't have the regular syntax like function, constructor, like usually have, because these functions are inside classes. We don't have to place the word keyword. As a matter of fact, we should not place the word keyword. And since we are talking about terminology here a little bit, these are called actually methods. Each time these functions are inside a class, they are called methods. It's better to refer to them as through the name methods rather than functions. And this one in particular, this special method called constructor, and we should just follow this name, we should call it constructor. It's a special function that basically runs automatically when we ask the blueprint to create an object for us. So how we're gonna ask the blueprint to create the object? How do we invoke this class and basically create an object out of it? Well, there is a special syntax for that. So let's say we need a person, this time uppercase P. By convention, usually people use uppercase letters for classes and constructor functions, and then lowercase letters or camel case for the other kind of symbols and variables. Okay, so let's have a person lowercase equal, and now we want to invoke person to return basically an object. We are not, well, when we build that constructor function in the previous lesson, we used to say just like that, call it like a function. This time it's similar. All we have to do is place the new keyword in front. Well, it's pretty easy to recognize each time we see a syntax such as a new and an entity. We should know that basically we try to instantiate a class. That's kind of the terminology that people use. In other words, this class will be basically used as a template to return an object, the object that we are taking here in a variable. All right, so let's run this program. Nothing happens, of course. We didn't print anything, but also the class is kind of empty inside. So let's go back to the class now and see a little bit, understand a little bit what's the meaning of this constructor function. And as I said, it runs automatically. So perhaps we should put here a println just to see it. Let's run the program again. Okay, we see hello. And notice we didn't invoke constructor, but each time this class is instantiated with a new syntax, like in this case, this function will be executed automatically. And then inside, of course, we can place other functions or other methods to say like that, but we'll extend it little by little. So let's focus on the constructor here. All right, so we are inside this class, and again we're gonna make use of that this dot keyword, like we used when we talked about objects. And this dot is basically, or this this keyword will be used to refer to the current object, so the current object that the class will instantiate, right? And since this is an object, we can basically create properties out of thin air, because that's what we can do in JavaScript. So let's create perhaps here a property. What the person has a first name, right? First name. And what what first name we should put to this person? One way to do it, we just hardcode it here. Let's say John. Well, like this. And then let's create another function. Basically, when we are saying this dot first name, inside this object that the class instantiate, we are creating the property first name, and basically we are assigning the value John. Similar to, again, how we did with the objects. It's similar to basically imagine an object is created at this moment, something like this. First name, and then the value is John, right? So this is what gets created inside when this constructor function is run, is executed. So let's see another member of this class. Let's have a function here, perhaps get name, like this. Again, we're creating a method, not a function. I use the word function just to make the things a little bit easier. It's similar to functions in a sense that the difference is that we don't get to use the function keyword in front, and the other difference is that we have to use the this keyword to refer to all the other members of this particular class, right? So let's say this one we want to return the name. So what we're gonna say, return this.firstName. Again, this.firstName doesn't exist in the class at this moment, but the constructor function will just create it automatically, and getName is returning it, right? So how do we invoke getName? Of course, we're gonna invoke it also with the dot notation. So let's have it outside here, let name equal, and we put the person object, the dot name, the not notation, and we say here getName, like this, and let's print it. All right, if we run this program, we can see John. And probably we read it. Let's have this one as txt. It doesn't matter, actually. It's somewhere inside this environment name is redefined. That was the issue. Anyway, this is not particularly useful class. We hard-coded inside this name. Let's see how can we pass exactly to a function when we instantiate the object. We pass some arguments, right? And the way we do that, we go here inside the constructor and add a few arguments, similar to how you add arguments to the function. So perhaps we should add an fname or first name. I'm using the same variable here as this one. We'll be able to differentiate them easily because inside the code to the argument we can refer to it exactly using the name, and to the property we always have to refer using the this dot notation. This is the special keyword that basically points to the object, and we can access all the other properties on it. Without this dot, if we just say here first name, obviously we're gonna refer to this argument that is coming inside the constructor. All right, so we are not hard coding now inside the name, but we can pass it as an argument here, like this. Similar to how to invoke a function, you can pass arguments to the constructor of a class. And if we run it, we see the same result. And let's have one more property. Perhaps this one has also a last name and even an age. And let's pass these ones, last name and age. And when we return, we can return a composite example, such as, let's say, first name and this dot last name. So let's instantiate this person. We pass the first name, we pass the last name, and an age. Timeless person. And all right, and we are invoking getName. So we should basically see these two first name and last name concatenated by this method and return. Let's run it. And indeed, we see John Doe. All right, so at this point, person is similar if it's to implement this one just as an example with a simple object. This would be similar to this. So let's say the entire code, we have it here commented. It's similar to have it like an object, first name, and then we put here John, and last name, we put it here. The other one, age, we can skip age, and then we can have getName as a function, and we can basically have the same body here. And okay, a comma here, and if we run this one, of course we're gonna get the same result. But I think we had enough with this syntax. We studied a lot in the past. Right now it's time to use a new syntax. So I'm removing that kind of snippet and going back to the classes, and our program runs perfectly again. All right, and you know, we can have other methods here. Perhaps we can have getAge, or we can have a function age, like we want the person to age, to increment age. And then inside here we can have this age plus plus, and then we can have a getAge that will basically return this.age. And in all this example, I'm just showing that we are working with these inner properties here, like with regular variables, with the only difference that we have to put the this.keyword in front of them. All right. So let's call some of these new defined method here. We can send person.age and say person.getName, or instead of getAge, we can say hi. And then we can say here hello from, and we concatenate with. Let's invoke one of the inner method here. And even if we're invoking a method, we also have to use the this.keyword in front. And then let's add a little bit more text. I am, and then age, this dot, and then all. Let's see. If we didn't mistake anything, we should have some really simple, really nice answer on the screen, basically, message on the screen. So instead of, okay, perhaps here, instead of get name, because we saw that one, and let's just call person. Okay, this one can print directly, or we can say hi here. And then we're gonna use the printing function to print it. And print is a special function in this environment. If you are working in other environment, just feel free to use console.log. All right, so let's run it. Oh, person.age is not defined. Somewhere we didn't, we have an error somewhere. All right, we called this.age where that's intended for just increasing the age. So let's use the variable, the inner variable, this.age. And let's name them differently. Age person. All right. So as you can see, it's working now. We just introduced a typical beginner error where we basically had two entities with the same name, both the variable and the method. All right, so it's working now. As you can see, it's pretty easy to work with classes. And as I mentioned, these are just blueprints. And exactly like with the constructor functions that we had before, it's really easy right now to create another person. And let's create quickly another person here, perhaps person 2. And gender, let's say it's 100 years old. And we can basically say hi. And we'll have two objects at this point. And see, they display, oh, this is displaying John Doe, we did something wrong. Person 2 here. Yep, is displaying differently and has different data. And these two objects are basically like two bubbles, each with its own data structure. So the first name, last name, age, they remained in the first object, and the second object has the same kind of properties. So it's like we have two collections of objects and they don't spill, they don't mess together, they are perfectly isolated inside the objects. And of course, this is a property of objects that we saw before, and we saw how easy it is to create this kind of bundles of properties and variables and keep them together in a nicely packed object. But now classes give us an ability beyond plain objects, give us ability to define object with a certain type. For instance, in this case, the type of object is person. We know ahead of time what kind of members this object has, what kind of properties, what kind of behaviors this object have. And also this kind of classes, they also act like this factory of objects. It's very easy to start from this blueprint and create objects really quickly using the new keyword syntax. All right, so perhaps this is a very, very simple example. Anyway, we're gonna save it and we're gonna start creating another example a little bit more engaging. So let me save this one, classes 1. And as always, I'm gonna place the code on the chat in case you want to refer to the code. Classes 1. And the program is on the chat. So let's start a new program right now. And perhaps we should create a little bit something more graphic. So let's have a class bubble. I'm thinking of the bubble that we had last time bouncing on the screen. So let's take it step by step here. So first, let's define a constructor function. Again, the constructor will be used to set these properties inside this object and, you know, set in its initial state. And how can we create a bubble out of it? Very simple, using the new keyword. We say new bubble. This time we have to open and close parentheses, similar to functions, because in case we have to pass arguments, we're gonna pass them here, like separated with a comma, like we saw. Anyway, we don't pass any arguments for now. This constructor function, the bubble is that basically that bouncing circle. Let's say this constructor is setting a this.x, which is then the x and y coordinates of a small circle, and let's have it at a random basically position. This.x and this.y, it's random at 600. Our canvas has resolution 800 by 600, right? So we have the this.x, the properties x and y set. Right now, let's perhaps visualize the bubble, and the way we visualize it, we're gonna create here a method display, and inside this method, we're gonna use the circle function to just draw a small circle at coordinates this.x, this.y, and perhaps an arbitrary radius of 5, or we can have that one defined as a property. That's something up to us. And now if we want to see the bubble on the screen, we have to invoke the display method, of course, on the object bubble. So we're gonna say bubble.display, and let's run the program, and we see a small bubble here. And if we rerun the program, we should see it in different positions because we made those x and y properties have random values, and the constructor is basically assigning these random values. All right, so perhaps this is classes to bubble. All right, let me save this one. It's pretty simple class, this one, much simpler than the one with the person, but actually let's extend it a little bit and have this bubble kind of bounce around on the screen like we had before, right? So we have the display method here. Perhaps we should define also an update method, and the update method, its function will be to update the x and y coordinates of the bubble, to increase them with a certain speed, and then when it reaches the edges of the screen, to make it bounce around. And we're not gonna do this on paper because this is an example that we are just redoing, this time in a new technique. So we're gonna try to type it a little bit somehow normally here in the code. All right, so the way we're gonna do is basically this.x, we're gonna add to this.x a certain dx value, right? A certain dx value, and we're gonna add to the this.y a certain dy value. And the reason we have update function, just as a small reminder, is because we want to define here a function loop. And inside this function loop, well, first of all, we leave the bubble creation outside of the loop, but inside the function loop, we want to basically clear the screen, then display the bubble, and then update the bubble. And this is basically, please refer to the lesson about animations, and if you want to learn more how loop is functioning, but in just a few words, loop is a special function that is called for us automatically by the browser up to 60 times per second. So using this function, we can achieve animation using this kind of pattern, display and update. All right, so we are back here. We don't have the dx and dy properties, so let's define them. And dx stands for direction or delta x, something like that. In our case, let's choose some numbers, perhaps random numbers between -1 and 1. If it's -1, goes to the left. If it's 1, goes to the right. And the same for dy, a random number chosen from the array -1 and 1. -1 will go up to the top and 1 goes to the bottom. And if we do this one, our bubble basically should just run on the screen. We picked a random dx and dy, but bubble is bye-bye once it reaches the end of the screen. So we have to take care of that condition. We can use some if statements here to verify if x becomes less than 0, or x becomes greater than 800, and the same with y if it becomes less than 0 or greater than 600. So we can say here if this dot x is less than 0 or this dot x is greater than 800, this being the size of the canvas, what we can do, we can have this dx, we can inverse it basically, and we do that by multiplying it with -1. We change the sign, and we can have the same thing applied to the y. So y goes basically from 0 to 600, and if it tries to go outside of the screen to these edges, we inverse the dx and dy. And let's run the program again. This time the bubble starts to the top, it hits the screen, and then should also work on this side. Hopefully works on all the sides, but I don't like that it's kind of slow. So let's have another property here, this dot speed, that perhaps it's 3 or certain value. And when we are increasing here, we can basically multiply by speed. So basically we are not adding just 1 pixel per frame to the x, but we are adding, let's say, 3 pixels per frame if speed is 3. So plus d plus 3 plus 3. So the bubble should move a little bit faster. All right. So let me save this one again. And if we run it, indeed, we have a bouncing bubble. I think is the third example. And what I want to do right now is, before we move to the other examples, let me just quickly, let me go and open again. We had them open bubble 1 here. Can open bubble 1, and perhaps we should open also bubble 2. Let's compare them a little bit side by side. All right. So this implementation is the one that we did today. It's with basically using classes as a template for these objects. And let's put side by side this one perhaps. And this one was using a constructor or a factory function to return an object. And inside the loop, the logic is the same. Basically, if we look carefully at the code, this is on the left. Again, this is the past example where inside the function, we created the object. We use the function as a factory, but if we notice closely, the display and update, they are strikingly similar. Actually, it looks like they are identical. Somehow we just replicated this one identical with the difference here that we had the radius. Here we hard-coded the radius. But of course, when you are basically faced with this problem, with the problem of implementing this kind of things, it's much preferred to have the version with classes. It's much cleaner, it's a much modern syntax, and basically classes, when somebody sees them, they understand pretty well that, okay, somebody defined here a blueprint and wants to use this class to create an object later on in the code using the new syntax. All right, so what better way than to practice this one than to basically create other examples. So let's plan to create one more example, not not more than this one, but I think one example would be really nice to create. Also something graphical perhaps. Let's think something graphical. Something with sprites. Yeah. let's do that. Let's have a class player. Well, who knows? Maybe this code becomes the base of your future game. So let's think like that. So let's have a class player here, and this player is basically a player inside the game. We'll have a constructor function that will basically instantiate a player on the screen at x and y coordinate. And to do that, let's use a sprite actually. I don't think we use this one. Or maybe we use it, but let's see how it looks like. So obviously this one creates a sprite. We want to retain this sprite in a variable because we want to refer later on to it. So we're gonna say this.sprite equal sprite. We use the same name. Again, this one is on the object as a property. We'll refer it to this dot. So JavaScript won't be confused which is which. So this one is supposed to instantiate a sprite at this coordinate 400, 300. Let's modify it and say it x and y, since right now it's basically, we already have an x and y as an argument to the constructor. And obviously the way we're gonna display this one, so let me save it first. Class is 3. This is player. We'll save it, run it, and nothing happens. Of course, even if we have a sprite here, this constructor never gets the chance to be invoked right now, so the sprite doesn't appear. So we have to basically invoke the constructor using the new keyword. So let's have a variable player that will keep the object returned by the new by the new class that is instantiated, and here we say new player. And we have to pass, since the constructor takes arguments, we'll have to pass some arguments. We can put 400 and 300, which is basically middle of the screen. And let's see if we have a sprite there. All right. We don't have any sprite in the middle of the screen for whatever reason. Let's see why we don't have this one. Oops, because I misspelled this one. Constructor. Not construction. So right now the sprite appears. JavaScript, as you can see, looks for this particular method, which is called a constructor. Actually, it's a terminology that is also very common in other object-oriented languages, and when it finds it, it invokes it. If it doesn't exist there, obviously cannot invoke it, right? So we had a different one, so that's why it didn't work. So we have a player in the middle of the screen. Nothing spectacular here. But basically, let's add some new behavior, and behavior means these new methods to the classes. Let's add perhaps a go left behavior. And the go left is basically will make the sprite go left here. So we're gonna use the this.sprite. Now, since we are taking in a property of the class, we always have to refer to this one with this dot. And the sprite has a property x that we can basically assign to make it basically, you know, to change the position on the screen. So when it goes left, let's say it goes left, we subtract from x a certain value. Or we can have this one like speed minus equals speed, right? So when it goes left like that. Let's have go right as well with a certain speed. And this time we're gonna add to the sprite x position the speed. And the easiest way to see these ones is obviously if we implement one of those loops and use two keys, perhaps left arrow and right arrow. If you are pressing the left arrow, the player should move left. If you are pressing the right arrow, the player should move right. So let's define a function loop. And inside this function, we can say if key is down of left arrow. Left arrow is basically a constant that says if key is down left arrow, then we'll do something. And what should we do? Obviously, we should call player go left with a certain speed. Let's put 5 here. Else, if key is down right arrow, we should make the player go right with a certain speed. All right, let's run this program. I'm pressing the left arrow, moves left. Pressing the right arrow, move right. It's working. Although it's kind of fun, it's kind of is gliding here, is sliding on the screen, is not walking, is not facing the right direction. So, you know, we can fix that. We can encapsulate all that logic to make the player mirror or change direction or basically change the animation. We can encapsulate it in here. And if I recommend you to watch the lesson about sprites, but basically what we want to do is when we are looking at the sprite, we see that it has different animation. We want to basically look here in this list. We want to change the animation to run. Each time we keep these keys pressed. So let's do that. This dot sprite dot show and we'll switch it to run. And here the same when it goes right, but we also have to mirror it to basically when it goes left, and mirror it with a positive value when it goes to the right. So we can take care of that one as well. Like in this case, this dot sprite dot mirror x of -1. -1 means sprite to be flipped to the left, and then here should be with 1 if we press the keys the other way. Let's run it. All right. It's one problem. My hands are out of the keyboard, but the sprite is still running. But if I'm pressing right, it moves correctly. Okay, so we have to take care of this aspect. If we are taking hands off the keyboard, basically the player or the sprite should just switch the animation back to idle state, which is the original state here. We start with idle state. The way we can do that, we can define an idle method here. Let's say this one will put the sprite into idle state. We don't have to do it this way, but let's say we do it in this way. So basically this one will show the state idle. And now inside the loop, we always try to keep the player inside in the idle state, unless these keys are pressed, and then basically when the method will be pressed, it will switch the state also to other animation. So let's run it. It's idle, run left, hand off the keyboard, it's idle again. So it seems that our player is working fine. Is moving to the left and to the right. You can imagine now an a really nice adventure game. Who knows? Who knows what we're gonna use this player to turn it into? But let's implement a little bit more behavior before we imagining this kind of animation games. Let me share this one with you on the chat. Again, if you are watching this, you can open it at any moment. Oh, I didn't share the classes too. Let me check that one first. So let me check classes 2, which is the bubble. All right, classes 2, that was the bubble. It's on the chat. And let me share with you also this player. And although we are not yet finished with this one, if you are opening and refreshing each time, you should get a new version. All right, all 3 programs should be on the chat. Let me run it again and see what else we can do to this character here. Perhaps if we press the up arrow, it should jump, right? And jumping is a very interesting thing in all these platform kind of games. There are different techniques to implement it. We also ourselves implemented in the past, I think, in 2 ways. So we're gonna implement it in a similar way to how we implemented in the past. Anyway, for this one, we're gonna define a new method here called simple jump. And the idea is that here we're gonna call it like this. If key is down, up arrow, then we're gonna say player jump. And see, this is the beauty of object-oriented programming and classes. It allows us to encapsulate all this functionality inside some class method, for instance, jump in this case, and forget about it. And as a user of the class or the object, I can just call jump. If a friend will gonna do for me this class, if we implement it, or if I'm downloaded from somewhere, a library of interesting classes, as a user of that class, I don't care about the inner implementation. I'll just call jump. I know that there is a method there that I can call jump and it's doing some interesting thing, and I don't have to think how it is implemented. So the entire code is encapsulated there, it's abstractized from me, but it's very easy to use as we see here. So now, however, for us will be a more challenging task because we are also the author of this library. So we'll have to implement it ourselves. So what can we do with this one? First of all, we can change the state to a nice jumping animation. That's easy. But we can also implement that thing when basically when we are jumping, we can change the velocity to go up at a very high velocity. But in order for the character to fall down, we also have to implement some sort of a gravity. Like we'll make the gravity always attract, basically make the character go down, and then when we jump with certain velocity high, but we also have to implement gravity, otherwise the character will just fly through the sky. So let's first make it fly through the sky, and then we'll see that we have to add that gravity. Yeah, let's change first of all this one to jump, and I think this character has the jump animation. Indeed it has. So we're gonna change it to jump, and then we'll also basically sprite.velocity.y. Y is the velocity on y-axis, equal minus 25, because when we are jumping we want to jump up, so we put an basically negative number here. So let's run it. Left, right, jump. Oops, doesn't jump. Oh, we said up arrow. I was pressing a different key. Okay, let's run it again. Left, right, jump. Bye bye. And jumping and never comes down. So this is fine for now, but we have to implement that gravity that attracts the player all the time down, right? Let's look at the idle. All right, you know, perhaps we should define here a method update, just to follow into that pattern, update display. So inside the loop we'll always call update, and update will basically try to bring the player down. So here the velocity on y, we're gonna increase it by 1. So we'll always increase it by 1. And notice that we are increasing by 1 with each frame. We are not assigning 1. We used the same algorithm last time, but the effect should be that when we are jumping, the velocity goes straight to minus 25, but for each frame we are adding 1 to velocity. So velocity should be minus 25, minus 24. At one point the velocity will become 0, and then will start to become 0, 1, 2, 3, and when this will get to positive numbers, will start coming down, right? So we're jumping and starts coming down. Of course we'll have to stop it now on the other end, because it will go down to the ground. But let's see how the effect here. So left, right, working fine. Up, jumping, oops, never comes down, because we are not calling update. So perhaps we should call update inside the loop. If we are looking there, we have the loop, and yeah, we should call here in here player.update, just like that. That's one way of doing it, but I'm thinking why we should call also idle and update. We can move the idle inside the update here. It will be much nicer. So right now inside the loop, our loop is cleaner. For each frame we're calling update to update its internal state, whatever that may be, and then this one to send commands. So let's run it. Oops. Let's run it again and press really quickly the jump. Okay, it's jumping, but comes down again. So as mentioned, we have to stop it basically here. So we can also make use of the update and verify basically the position. If the position is bigger than, or when it goes down, tries to go higher than a certain number, right? So what number? We can stop the character when it goes outside here at 600, or we can also stop it basically when it tries to go beyond the initial position where we place that one. So perhaps that one is better, but let's stop it at 600 first. All right, so we're going here and say if this.sprite.y, if it's greater than 600, obviously we want to stop. We want to set the velocity to 0. We don't want to fall anymore. It's also good to set actually the y to reset it at certain value, just to not to have that tunneling effect. Maybe it goes more than 1 pixel and it goes a little bit down with each jump. So it's good to have it this way. So let's see. And we are jumping and stops there. All right, and notice that actually stopping at 600, but for sprites, the hotspot, the origin, it's in the middle of the sprite. So that's why it stops correctly, but the jump is quite nice. And oops, so two problems. Obviously, we want to stop it at a different coordinate, perhaps the original coordinate where you instantiated the sprite. And second, we can jump in midair. So see, I'm pressed. We should jump only when we are standing, but if somebody presses the jump again while the character is in mid-air, we should not jump again. So we can fix this one really quickly. So first of them, instead of 600, let's stop it at the original y. For this one, let's store it perhaps in a y variable here. We can store also x, but for now we are just interested in y. We store it, and then we say here, if this becomes greater than this dot y, which is that stored value, we are stopping. So let's jump. All right, it is okay. And now we have to also solve the problem with double jump. So how do we know if the character is standing or it's basically jumping? We can do this in two ways. We can have a flag variable here, such as a state, like we did last time. Perhaps the state is jumping or state is standing. Some property like this one, and then when we press jump, we switch the state to jumping, and then we switch back the state to standing. That's one way. Another way, we notice that because we use this technique, velocity becomes 0 when it's standing here, right? Also, not only velocity, but basically the y coordinate. If the y coordinate of the sprite is the initial coordinate, it means that the character is standing, right? So what we can do, we can have perhaps here, we should go here. We can have a property, a Boolean property that will return a true or false, is standing. We are asking, is this character standing? And this one will return, basically what will return? Will return exactly this. If this sprite is equal to the original y coordinate, then it's standing. Here we'll have to put triple equal, not a single equal. A single equal means assignment, all right? So right now it's standing. So let's make use, it is a method that we can invoke it at any time, and we can ask this object, is the character standing? And of course, we're then gonna check this one and return true, and this one to match, or false if it's jumping. So we should make use of basically this is standing property here. So when we go to the jump here, obviously we want to say something like, if he's not standing, is standing. We could have named the property is jumping, but we name it standing. So right now we have to negate it, or say if it's not standing, means that if it's jumping already, we return. All right, that's one thing. I think we have to do it in multiple places, but let's see. Jump, oops, is standing is not defined. This dot here, if this is standing, and if we run it, all right, we don't have middle jump. But all right, looks kind of okay-ish. Yeah, looks kind of okay. Let me save the program. You can also try it on your side if you want. So if we are going, let me run it again. If we are jumping, it's fine. It's basically, yeah, everything should be fine. It's let me run it again. What's the, just to check. Usually there are combinations when you are, yeah, one thing that I don't like, yeah, I found one. I knew I would find something. Notice when it's jumping, first of all, let's switch the animation to jump. It doesn't show jump. All right, yeah, it doesn't show jump. It's kind of, character is idle. It doesn't have that double jump, but the character is idle. And I think I know why it's idle. If we go in update here, we are calling idle all the time. So basically we should call idle only if it's standing, basically, if it's not jumping. So this time we're gonna say if this is, because in the mid-air, when it's jumping, we should remain in whatever state it was there, basically, which was basically jumping. Right? Because when we are jumping, we are trying to show the state to jump. So right now is basically, let's see if this correct. Okay, we are jumping. All right, now in mid-air, it's in jumping state. Let's move it a little bit down to have more room to jump. So instead of 400 and 300, maybe like 450. I don't know, something like that. Yeah, let's jump. All right. All right, one other thing, I probably can, yeah, it's fine, but maybe you can do this one as well. It's up to our preference. In mid-air, if we are jumping using a combination of both keys, both up and right or up and left, notice that using single up, the animation is looking like it's basically jumping, but if we use both, the animation changed to running. And that's because here this one forces the animation to running. So perhaps we should do the same. We should not force the animation to running unless this is standing. So the same as we did here in the update. If this is standing and we are trying to move left and right, then only then change the animation to running. Yeah, only then. I think this will look nicer, because we don't want to look like we are running in thin air there. So let's do the same here. And notice that I'm just encapsulating this one inside these methods here, but as an user of the class, I didn't change the code. As an user, I'm still using pretty simple commands. I'm saying go left, go right, jump, everything is encapsulated inside the class. Let me run it again. Go left, right, jump, nice animation. Okay, and jumps also on diagonal. I like it better this way, not to show that it's running, but if it's standing and you try to run, it's basically running beautifully. I think we accomplish our kind of character. It's kind of a little bit bigger, the code here, but notice how the usage of it. It's pretty simple here, right? We call player update, player go left, go right. We call jump and so on. So it's a kind of pretty good encapsulation using the classes inside this one, right? So what can we do? What can we do? Let's place, first of all, before we figure out what to do, let's place a nice background here. Yeah, perhaps I should choose the jungle. This jungle looks interesting, kind of interesting, right? So let's have it here. Not this one, the jungle. Let's see how it will look like. It's like we really start an adventure here. All right, so now, you know, we can basically do more things here. One way we can update this class even more, and let's continue this exercise perhaps a little bit more, shall we? I hope you like it. Is to basically, one way we can leave it like that, we can leave all this moving behavior outside of the class, like if we press the left arrow, go left, if we press right arrow, go right, and so like things like that. Perhaps we want this logic to sit in another place. That's very valid situation. But we can take even further this class and actually encapsulate this one like behavior inside the object. So in the moment somebody just instantiate this player, it already moves. It's like this object has built-in moving capabilities. So let's do that one just for fun here. Maybe it's good. So let's take all this all this code here. Yep. And go inside the class. After update, we can define another method, read keys, like we read the keyboard, right? So we read the keyboard and we paste this code. We'll have to modify it a little bit. Instead of player, since we are inside, we say this, right? We say this, and this if we press the left arrow, if we press the right arrow, and so on and so forth, right? So right now for us it will be in here we can call player.read keys, but we can do the same thing that we did. We can go inside the update basically there, and we can call read keys from inside the update. Why basically otherwise have that update there, right? So let's do that thing as well. We can call it perhaps at the end here, exactly like it was before, read keys. Oops, let's not forget this dot, and if we run it, our character moves. But now the encapsulation is even stronger. If we look really closely here, we just, let's say somebody creates this player for us, we say new player, and then inside the loop all we have to do is call player update, right? Besides other things that we want to do there, we call player update. I don't like though the update function. Perhaps this we should move this one in a smaller function, a smaller method. Let's do that one. So yeah, let's define another one here, update. Perhaps this is for updating character, so let's call it update character, something like this. We move this one and we put it here, and inside here we say this dot update char. Should do the same. Let's run it, and then we're gonna review the code. Yep, it's doing the same. Now notice something. We are calling from outside here player.update. We should never call update char or read keys, because this one are called from the internal update. And it's a common concept with classes and objects to have some internal members that are called private members. So in our case, update char and read keys are private members. They are not supposed to be called from outside by the user. They are just called from inside. And right now nothing prevents us to call them from outside. I can call here player.read keys, but I should not do it because update is already calling that one and I'll mess up the program. And because I should not do it, there are some techniques to mark this one as private and make the program kind of protect them. Some languages have, other than JavaScript, have even better mechanisms protecting some members. Some people just rely on conventions. For instance, they use private members, they start them with a certain character, such as an underscore. There are also other methods, but of course we'll not go into that one. For now, I just wanted to mention like a parenthesis, these are supposed to remain private. What we are calling from outside actually at this point actually we are calling just update. We made private even the go right, we made private the jump, go left, is standing, all this we made them private. Or perhaps we should not, perhaps is standing is still useful if we want to from outside to check is the player standing or jumping. So anyway, but for sure update it's a public member, how it's called, because it's supposed to be called from outside. Alright, so let's run it again, and the player is just jumping and walking on the screen happily. So what else can we do to this one? Perhaps we should, let's see, let's check this, this sprite. All right, it has also a shoot kind of animation. Perhaps we should also implement a shoot basically. So if we are pressing perhaps space key, it should shoot. We are in a jungle, perhaps big spiders are coming or big dinosaurs, and our character will shoot these spiders and dinosaurs coming towards her. Right? So let's do similar to how we did with the jump. We should have a method here, shoot. And we should invoke this one from read keys. So if it's up arrow jump, if key is down. And again, as we discussed last time, I don't know if there is any constant for the space, but 32 is the key code for space bar. So that's why you put here 32. This dot shoot. All right. So now it's shooting, but nothing is happening here. Just to make sure that it's working, we can print something. Shoot. Just to make sure that this one is working. Press space, and indeed it's working. But we have to implement it. What can we do? First of all, we can change the animation here. We can make the sprite this sprite.show, and I think it was called shoot, right? So if you are pressing this, we change the animation to shoot. Let's try it. All right, it's working quite nicely, and it's staying the shoot animation as long as I'm pressing the spacebar. When I'm raising my hand from the keyboard, it switched back to the idle state because of that update cycle that is going there and changing this to update. All right, and can shoot also in midair, which is nice. Yep, it can also shoot in midair. All right, so we can have spiders coming from different ways. But the question is, should we shoot what right now at this point? And what we can do, we can have this, and I think we implemented in that space battle game that we did, or mini game that we did in the past, to use those custom defined sprites with the rockets. Let's combine in this one though. Let's see if I have here. Yes, indeed. If we remember from one of the previous lessons, in this environment in CodeGuppy, we have a layered environment. We have sprites combined with graphics at the same time, so we can basically use at the same time sprites, and we can use also graphics on a different layer. So let's use basically this technique and actually make the bullets. We'll render the bullets using small circles. We're gonna not use sprites for these bullets because we want to see how to combine both sprites and regular graphics drawn with circles. But nevertheless, since we are at the lesson about classes, we're gonna model the bullet and perhaps not only one, but all the bullets that is shooting using classes. So let's start with modeling a single bullet. All right. So we go before player here. Let's say class bullet. And this basically is encapsulating the behavior for a bullet. So what a bullet, first of all, let's define a constructor. The constructor will be responsible for creating a bullet, and a bullet will basically, main properties will be that will have an X and Y, right? So it's shooting, and actually it should have also direction, because if it shoots to the right, the bullet should go to the right, and if it shoots to the left, should go to the left. So has an X and Y and a direction, right? Like this. And we can, and we can basically store this one. Let's store this in some properties. This dot X is X, this Y is Y, this dot direction is direction. Direction, I'm thinking just to have a -1 or 1, left or right. And let's also add a speed to the bullet. Bullets usually are going at the same speed, but maybe it has a nicer effect if we can have a random. Maybe a random number between 10 and 20 is moving 10 to 20 pixels at a time. And now we're gonna use the same pattern. A bullet will have an update method that we're gonna call it to update its position, and should have also a display method that we're gonna call it to display the bullet. So it's a common pattern to basically do this one, right? So this dot X, we are increasing the position to the bullet by speed multiplied with direction, I think. Yep. This dot direction, so it should be 1 or -1, and times this dot speed. Because if direction is -1, it's basically going the other way around, right? And now for display, we're just gonna say a circle at this dot X, this dot Y, and the 5 radius. Perhaps we can even fill the circle with a certain color. Is this a nice color for a bullet in a jungle adventure game where a character is shooting spiders and prehistoric dinosaurs? I don't know. But okay, so we have a bullet, I define it, but we still, I think we need more than one bullet. What we can do, since the character can shoot multiple bullets, let's define a collection of bullets, right? So we can do at this point, we can have an array of bullets like we did in the past, but we can also have a collection or another class called bullets. Let's have that one. And I hope that I wrote this code correctly. I'm just running it to not have syntax errors. We cannot check the code yet because we have to invoke it, but by running the program, we can check if we have syntax errors anyway. So let's have another class here, bullets. and this one supposedly keeps an internal array of bullets, but it's not a simple array. From outside, these bullets class also has the ability to display all the bullets at once, or to update the coordinates of all the bullets at once, right? So yeah, so let's see, what do you need for a collection of this one? Obviously we're gonna need to have an internal array to keep this one. At the end of the day, we still have to keep them in an array. Yeah, let's have this one. So let's have a constructor. Yeah, I spell it correctly. This dot bullets, that will be our internal array, which is empty here, right? And then let's have an add method. Add or push, we can have add for now. That would add a bullet inside the collection, like this. Boom, add a bullet. We're gonna pass the bullet object. So from outside, we can basically create this this object, and we're gonna say to the collection, add it. So basically this one, we can just say this dot bullets dot push, push the of bullet, right? It's like this. So we're adding here a bullet, and let's use the same pattern, an update method that will make the bullets basically move. So at this point we can move the bullets on the screen, and then the display method to display all of the bullets. And we can combine this one. In order to do the update and display, we have to loop through all the bullets and call their individual update and display. So we'll have two loops going on twice, basically, one going for update and one column for display. If we combine them, we can just have only one loop. But since this bullet collection is not big, we can leave them separated just because it's much clearer to see. So let's implement display, because this is easier to implement. So what we can do is we iterate to this bullets collection. So for let bullet of these dot bullets. So each time we are referring to an internal member, basically, or to a class property or method, we have to use the this property. So I'm gonna just call bullet.display, like this. All right. And update, why I left it to the end, it's a little bit more complicated. Obviously, first of all, we have to iterate all of them and update, call update. And when we're gonna call update, basically, you know, the bullet will just change its X coordinate, but it's a problem. As the character is shooting and shooting, the bullets collection will grow bigger and bigger, will grow to 1,000,000 bullets there. So it's not necessary to have this one, because once the bullets go outside of the screen, we can remove them from the bullets collection, right? They are lost bullets. So all right, so if we want just to call update on the other one for the moment, let's just call update. We should take care of removing them later on. Let's just implement the same logic here and call update, because I'm eager to basically wire these things together and see it. So here we have to come back. Let's put a to do. So we call update, that's fine how it's called update, but then we have to put here, probably here, to do remove bullets that go outside canvas. All right, but for now let's wire this up, because I think this is enough for the classes, but we want the player to basically, when he's shooting, we want to see some action happening on the screen, right? So right now the player, all he has to do is basically to create in the shoot method, we have to create a new bullet and add it into the bullets collection, and hopefully basically things will just happen. So let's do that one. So we change the animation to shoot, but we also say let bullet is new bullet. We instantiate the class bullet, and I think this one takes an X and Y coordinate, right? And the direction. Oh, even so. So we'll instantiate a bullet at what coordinates? Can be at this dot sprite dot X. So the current position of the sprite, right? This dot sprite dot Y. What will be the direction though? Because direction is should be 1 or -1 if it's you know what we can do. So yeah, we can go in the go left and go right here, and we can also store, if it's going left, we can say this dot direction equal -1, and if it's going right, is this dot direction is 1. And let's have it this one in constructor as well. So initially, supposedly this direction is 1. I think the character is basically facing right initially. So yeah, we are fine. You know what we can have also in the constructor? We can instantiate the bullets collection here. So let's say this dot bullets, and we can make a bullets like an internal member in the player. Is like the player, the character has bullets on its own. So it makes sense the bullets to be a member of the player. So, and not an outside object. So we can instantiate it from inside the object, from inside the player, not from the outside how we instantiated the player. Another way would be to have the collection of bullets outside here, but it's much better to be inside. Imagine if we have two players, right? Each player will keep their own bullets collections. Otherwise, if we instantiate it from outside, all these two players will have to share the same bullets collection, which, okay, maybe it's good, maybe not, but I think it's all right to have it instantiated inside here. And if it's an inner member, private member inside the player. So we now go back to okay, to the shoot. Now we have a direction, is this.dir. And now we not only that we have a direction, we also have the bullets collection there. So we can call directly this.bullets.add. I think add is the method that we added to the bullets, and we add this bullet into the collection. All right, so we wired up. Each time we are shooting, we are creating a new bullet and we are putting it inside the collection. And this is fine, but we still have to do one more thing, because if we run it, nothing will happen probably. Unless an error. Yeah, nothing will happen. It's good that nothing is happened, because the worst could have been an error at this point. And the reason is because we are not doing anything to this bullets collection. We are not calling its update, and we are not calling its display method. So where is better to call it? Well, since we placed this one inside, obviously we can call it from within the update of the player, right? So we can call this dot bullets dot update, and we can call also the display here. Or you know what? Just to keep the pattern, we can have also a display method here. Player will have a until now the player had only update. We didn't have the need to have display for the player because the sprites are auto displaying. We don't have to draw them. Once they are on the screen, we just need to update their positions and they just move there. But for bullets, we need to basically display them because they are circles and things like that. So we can put the display inside, but just to keep update separated from display, we can have the player having an update, and basically for this one we just use it just to display the bullets. We don't have to display the character or to do any other things, just display the bullets, right? So we still also have to call it this one. So perhaps here inside the loop we're gonna call the regular update and then call the display like this. Let's run it. I'm curious to see this time. Oops. All right, and we have plenty of actions here. Spiders will have no chance. So yeah, we have to clear the screen. That's what we have to do. We can also encapsulate the clear inside, but perhaps not, because if we have other objects there, we don't want each object to call clear. We want to do one clear for everything, so it's okay to leave it separated. So let's see. All right. And we have lots of bullets there. We have to do one more thing. We have to go back to that to do. Yeah, and these bullets, as I said, we always adding them, but we never remove them. So we have to take care of basically removing the bullets. So we have to check basically if a bullet is going outside of the screen. If it's going outside of the screen, then we remove it. If not, of course we don't remove it. And we should use a better for this one. Remember, when we have to remove an item from an array, we can use splice, but also said that it's best to iterate the array from end to front, just to avoid reindexing of the array and doing all sorts of crazy things there. So let's have a for loop instead, or regular for loop instead of a for off. So I starts from this dot what is bullet dot update here? Oops. Huh. Let me go back. Oh, yeah, that's fine, because this one was coming from the for off. So for I equal this dot bullets dot length -1. So this is the last element in the array. As long as I is greater or equal than 0, I minus minus. All right. Now we can take in a separate variable. Bullet is this dot bullets of I. And we can call update like we called until now. That's fine. But now we have to say something like this. Let's say if bullet is outside, so basically bullet is outside of the screen, this dot bullets dot splice at index I only one element. So if it's going outside of the screen, we have to remove it. So let's implement is outside basically, because the bullet class doesn't contain that one. We can implement it here, is outside, and basically it's outside on the x. So it's return if this dot x is less than 0 or this dot x is greater than 800. So at this point basically it's going outside of the screen, right? So we should be fine. And just to make sure that the bullets collection doesn't grow and grow, let's temporarily here, what we're gonna do inside the display for the bullets, we can also have a text, this dot bullets dot length at 10 and 30. We display how many bullets we have in the collection. So let's run it. We have 0, notice there. You shoot for, okay, many bullets, and goes back. All right. So see, it grows, but also go back to 0. So we are not losing memory. We don't have memory leaks with lost bullets. So it's fine. Our code is fine. We can remove this one. All right. So this is the code. We wrote kind of almost 200 lines of codes. But now notice here how neatly encapsulated is all this functionality. All we have to do is to basically, supposing this again, that fictitious scenario, somebody creates the player for us and say, okay, to use the player, just, you instantiate it and then just call this one inside your loop, and the player is automatic, it shoots, it walks, it runs, it jumps. How easy is to use this one? It's very easy. And all this encapsulation helps us basically. And actually, let's see this encapsulation in effect and create two player objects. Let's say we have two players, player N1 and player 2. And perhaps the second one, so this first one is at 400. Yeah, perhaps let's make this one at 300 and 500, like different position, not overlap. All we have to do, similar to the first player, also call these methods inside. And let's see how it's happening. What's happening? All right, so we have two players. Let's see what's happening here. Player update, new player. All right, something it's a little bit problematic here. Something player update, player 2 update. All right, when we are running, they move correctly, left or right. They even jump. But one of the players, the animation is not changing, and the other one, it's kind of funny looking. So let's inspect the code here. I think we have an error somewhere in the jump or go right or go left. This does sprite. This does sprite. Somewhere here we have a small bug. And now we have to start a long session of debugging. So let's see if we can spot this one really quick. If not, it's not a problem. It's not a problem, at least working with classes. But if you want to continue this game, obviously we'll have to fix it. So for whatever reason, so new player, okay. Let's call. Do we have any side effect? No, should not be any side effect in any case there. Of course not. So which one is which? The one on the left is our original one, right? So let's put them back the other way. The one on the left is our original one, and the one on the right it's the other one, right? So let's comment them again, these ones. Oh, we have one remaining there. For whatever reason, that one shouldn't remain there because we are not calling it. So this is working fine, it's jumping, but in the moment we introduce the second one, so oh yeah, we are actually calling it here. Yeah, of course. So player 2 is here defined, and player 2 update. If we call the player 2, yeah, something is not happening all right here. We have to go starting with the update method, see what's happening inside. We update the character, we read the keys, and then we update this one. So this jump, this shoot, this shoot. So this is happening for each, basically for each character. Go left is calling its appropriate go left method. Let's read keys. If we look at shoot, this is standing. Sprite direction. All right, it's a very fine error. Somehow is escaping here. Anyway, if you find the error, please leave a message in the comments. Anyway, this is outside of the scope of the today lesson for classes. And also we don't have intent to build a full game today, because otherwise we'd be named the lesson building a game. We actually wanted to have some fun with classes. And today, just to recap what we did today, we did 3 classes. The first with the person, the second with the bubble, and the third one, this one with the player. That also has some additional small classes like the bullet and bullets. And we saw how we can combine the player with the bullets, how we aggregating them together. And we even managed to introduce a bug in here. So yes, this is the entire code. I put it there on the chat. It has almost 200 lines, this one, but as you can see, when working with classes, we actually is not difficult, and the effect is quite interesting. We get the chance to encapsulate lots of functionality and then use it later on, reuse it later on, and this is the power of classes and power of object-oriented programming. Of course, we just scratched the surface right now. We mostly talked about how classes help us create blueprints for objects. We also talked about how classes encapsulate and abstract things. In the next lesson, we're gonna see other benefits of object-oriented programming and classes, such as inheritance, and things will get basically to start getting a little bit better and see more power of classes in our programs. All right, so for now, I put this one in the chat already. I'm thanking you for watching. I'm saying happy coding, and see you next time.